In this recording, we're going to learn how to factor using the greatest common factor, or GCF. First off, we need to know how to find the GCF of two numbers. That's sort of like prerequisite material. So GCF, greatest common factor, well, one way to do it is just to list out all the factors, all the numbers that go into a particular number. Like, these are all the factors of 12. These are all the factors of 18. So what I want you to find is what's the greatest common factor, the biggest number that goes into both. So as I'm looking through this, I should be able to find, well, 1's in common, 2, 3, 6. Well, it looks like the greatest common factor is 6, the biggest number that goes into both. Okay? And so if you're lost, if you have no strategy, one strategy is just to simply list out all the factors. Okay? So hopefully you have another strategy besides just listing out all the factors. You can just kind of reason about the numbers. Find out the largest number. Now 3 doesn't have very many factors. So you're thinking about, okay, well, 3 only has 1 and 3. What's the largest factor that goes into both 3 and 12? Of course, that would be 3. Okay, so why don't you work on part B and C, pause, play the recording when you're ready. Okay, so for 16 and 24, largest common factor is 8. For 15 and 25, the greatest common factor is 5. Now let's talk about what to do with variables, because if you can combine your knowledge of numbers, greatest common factor, and variables, greatest common factor, you can put it all together and be a greatest common factor machine. All right, so x to the third and x to the sixth. Got to concentrate here. Let's represent x to the third in expanded form. Same with x to the sixth. Okay, so I want to know what's the greatest amount of x's that is common to both terms. Okay, so I got 3 x factors here, and there's also 3 x factors here. So what's the rule? So the GCF, I guess, is x to the third. So what's the rule? What you're going to do is for variables, okay, so for variables, use the smallest exponent for each variable. So let's do one of these together, and let's have you do the remaining one. So let's do part E together. Okay, so the way I'm going to approach this, I'm going to kind of talk out loud, think out loud here. My thought process is I'm looking at 6 and 15, the coefficients first. Thinking, what's the largest factor of 6 that also goes into 15? So 6 doesn't go into 15, I'll go one less. 3. 3 goes into 15, so I'll say it's got to have a 3. And then for the x's, I'm taking, remember, the smallest exponent for each variable. So it doesn't matter that 3 doesn't go into 4. It's the fact that x cubed goes into x to the fourth. So I want the smallest variable, x to the third. Okay? Can you work out B? The second B, I'm not sure why there's 2 B's. It's probably because this is supposed to be an A. Can you work out A, B, C, and D, and then play the recording when you're ready? Okay, so hopefully you worked these out. If not, please pause and do so. So y squared, just a simple 2. 3 x squared, so the GCF of the 3 and the 12, and then the smallest exponent of the variable. Then for this one, we have a 2y squared. Now we're ready to put it together. So on the next page, we're going to factor this expression, 3x squared plus 9x. We're going to start by looking for a greatest common factor that goes into both. So let's kind of follow this recipe. First, what's our GCF? So hopefully you recognize it's got to have a 3, and it's got to have an x to the 1, or just an x, because that's our smallest exponent. So next, set up a 1 by 2 window. I got our GCF over on the left side, and the 2 terms of the expression to be factored inside the window panes. Okay? Now we're asking ourselves, what must be my factors that I would need to multiply 3x by to get a 3x squared? So that's just an x. And what would I need to multiply a 3x by to get a 9x? And that's just a 3. So the factored form, in other words, I'm sort of undistributing, if you like. I'm going to write the GCF out in front, and in parentheses, I'm going to write the other factor, the x plus 3. Okay, and you can mentally distribute it back. 3x times x is 3x squared. 3x times 3 is 9x. So it works. So we're going to try that approach for 3 example problems. We're going to do 1, 3, and 5 together. Okay. So first off, what's our GCF? So hopefully you could write down, okay, it's 4. 4 goes into 24, and 4 is the biggest number that goes into 4, so I'll go with a 4. And now I'm looking at the x's. Well, there's no x factor in the 24, so it's just a 4. In terms of my window, I'm going to write a 4. Matter of fact, I'm going to start a little bit lower because I need a little space above. So I'll start here. I got my window. And each term, remember, terms are expressions separated by addition or subtraction. So each term gets its own window pane. The 24 gets the negative sign. 4 is my GCF, so I'm sort of undistributing here, and I'm writing 4 times what makes x squared? Hopefully you thought x squared. And then 4 times what makes negative 24? Hopefully you thought negative 6. So that means the factored form has 4 on the outside and x squared minus 6 on the inside. Sort of undistributing this by taking out the greatest common factor from each term. I'd like you to work on number 3, identify the GCF, and try to set up your window. Play the recording when you're ready. Okay, so hopefully you recognize it's n squared, smallest exponent. Don't forget that negative sign that is associated with that n squared. Now finish it off, guys. Can you please put on the top, what are the factors when you factor out an n squared from each of those terms? And so if we have an n minus 1. And of course we can check it by distributing. Last one we're going to do together. Let's do number 5. You go through the whole process on your own, come up with the factored form, then play the recording to check your work. All right, so hopefully you came up with a 4 as the number. 4 goes into all the terms, and then x, or x to the first power, largest exponent that's common to everything. So that's I should say the largest exponent that's common to everything is the smallest exponent. So I've got 4x okay, so there's my factored form. I can check it by distributing, and it looks like it all checks out, except I put in a minus sign where there need not be one. That is good that I caught that by checking. It should be a plus. Thanks for watching.